All right, so welcome back. So today we're going to take a look at graphing our exponential functions. So the exponential function is a function in this format. F of x is a times b to the cx minus d plus e. A, b, c, d, and e are all just simply coefficients, constants, numbers that involve the problem. We don't necessarily need to always have a number for c, for example. In fact, most problems will have no coefficient for x. We don't need to be extracting a value like d from that expression or e as well. B has to be something obviously there, otherwise there would be no exponential. B can't be 1 or 0, otherwise the whole thing just kind of goes away. And then A also technically doesn't need to be there. I don't technically need to multiply with that. So to create our graph, we're going to be finding a couple different concepts to go with our graph. The idea of domain and range, where the function exists horizontal with the x's and with the y's. The idea of the horizontal asymptote, related back to the rational functions from Unit 3. And then the three special points we're going to use to make this graph. So domain range will be very straightforward. For exponential functions, domain will always be negative infinity, positive infinity. There is never a time, never an x value that will cause the function to be undefined. Range, on the other hand, will depend on whether a is positive or negative. If a is positive, the range goes from e, the number at the end of the equation, to infinity, whereas if a is negative, the range goes from negative infinity to e. So it just kind of depends on a being positive or negative in front. The horizontal asymptote is the value the function will be approaching as x gets either very small, when b is a number greater than 1, or very large, when b is a fraction in between 0 and 1. And the horizontal asymptote will always occur at the value of e, which makes sense because that's part of the range. That's its limiting factor right there. And as for the three special points, well, because we're making an exponential function, sometimes, depending upon the problem there, we want to have nice values to plot on our grid to make our overall curve. Like we know an exponential function curve is going to look kind of like this, go flat and then vertical, or it can go like the other way around, vertical then flat. It can also be like, a negative kind of thing, so go negative and then flat, bunch of different options. I guess technically flat then vertical in the negative direction. Those are the four different types of graph shapes you'll see over the next couple of slides. We're going to use 3 points to do that. The three main points we'll use will be setting the exponent portion, the cx minus d, equal to negative 1, 0, and 1. Because those are the nicest numbers, because if I have like 2 to the negative first power, I get a half. If I have 2 to the 0 power, I get 1. If I have 2 to the first power, I just get 2. So they're nice values that will work. I won't get super massive numbers because of it or super tiny numbers because of that. All right, so for this function right here, we need to identify domain, range, horizontal asymptote, and special points. So domain, negative infinity to infinity, always. Range, well, a is that 4 in front, e is the negative 4 at the end. So if it's positive, we're going to go from e to infinity. And also that's where horizontal asymptote is occurring at, that negative 4 value. So when it comes to making our graph, we know we are going to have that dotted horizontal line at negative 4. Now for our special points, we're going to set x minus 1 equal to 0. Negative 1, sorry, we'll do that first. X equal to 0 and x equal to 1. And we're going to see we're going to work with x equals 2. 0, because that's a negative 1. 1 and 2. 0, 1, and 2. To find our y values, we're just going to simply substitute that value of x into the function. So, for example, I'll write it out for the first one, and then from there, you're just going to kind of fill it in on your own there. So we're doing 4 times 2 to the 0 minus 1 minus 4. So you just type it out exactly like that. 4 times 2 to the 0 minus 1 minus 4, and we get a negative 2. And then 4 times 2 to the 1 minus 1 minus 4, we get 0. And then 4 times 2 to the 2 minus 1 minus 4, we get 4. So those are our special 3 points. And again, those are simple enough that even if we didn't have a calculator, we could do it by hand, because 0 minus 1 is negative 1. 2 to the negative first is 1/2. Half of 4 is 2. 2 minus 4 is negative 2. And there's our number right there. And we find the same thing plugging the other values into it. Anyway, we plot our points 0, negative 2, 1, 0, and 2, 4. And we can see there's our flat line curving upwards, hit our points. And there's our exponential graph. And I'm going to show this, we're going to do 4 total graphs here. I'm going to be alternating A being positive and negative, and I'm going to talk about the base being an integer versus a fraction and how that shows a different graph. So this graph right here is showing us what happens when A is positive and B, the base is bigger than 1. That's our first example. All right, so this example right here, we can see A is now negative and B is again still bigger than 1. We still go through the same overall process. Our domain, negative infinity to infinity. Our range, this time because A is negative 2, we're going to go from negative infinity to E, which is 8, which also, again, is our horizontal asymptote. As far as our special 3 points, so it's x minus 5 equals negative 1, equal to 0, and equal to 1. So when we do our points that we're going to find, our x values are going to start at 4, 5, and then 6. So we work through that. So we have negative 2 times 4 raised to the 4 minus 5 plus 8. We get 7.5 there. Negative 2 times 4 raised to the 5 minus 5 plus 8. We get 6. And then negative 2 times 4 raised to the 6 minus 5 plus 8, we get 0. Simple matter of just typing into the calculator there, nothing too crazy. Horizontal asymptote occurring at 8 points, so we would have 4, 7.5, so somewhere in between 7, 8, right in the middle. 5, 6, and then 6, 0. You'll find is that the bigger that you're going to have the value for the base B there, or the smaller fraction, the more of a vertical drop-off it's going to be. So again, we're going flat along the horizontal, and then we're hitting those 3 points and kind of just going straight down. And that's all I'm looking for these kind of graphs. So those are our 2 scenarios when B is positive, or B is just in general bigger than 1. So the next 2 graphs, you can see B is a fraction, but it's not going to change our overall process. We're still recognizing that our domain is still, as for all exponential functions, negative infinity to infinity. Our range is still based on the fact that A is a positive value. E is 1, so we're going to go from E to infinity for the range because A is positive. The horizontal asymptote would occur at y equals 1 because that's where E is. Our 3 points are still the exponent equal to negative 1, 0, and 1 because those are going to give us the simplest 3 points to work with. And part of the reason why we want 3 points is we want to be able to show it's like an actual curve, they're exponential. If we only plot 2 points, you might accidentally think it's a linear line. So by showing the third, we can see there's a curve to it. We get negative 4, negative 3, and negative 2. So filling that in, 2 times 1/3 raised to the negative 4 plus 3 plus 1, we get 7. 2 times 1/3 raised to the negative 3 plus 3 plus 1 gives us 3. And then 2 times 1/3 raised to the negative 2 plus 3 plus 1, we get 1.6 repeating. As a fraction, it's really 5/3, but we want to think of it more as the decimal. Makes it easier to plot out our points. So we're going to do our dotted horizontal line at the E value, which is 1. Negative 4, 7. And then we have negative 3, 3. And negative 2, negative 1.6 repeating. You can see now it's the opposite. We're going to be going flat on the right side here because the B value is in between 0 and 1. And vertical on the left side. So I'm going to come from here on the right, hit our points, and go up. So whenever B is a fraction, you're going to see it's going to be flat on the right side, vertical on the left, either up or down based on A being positive or negative. Whereas if we look back at the previous examples, here B was bigger than 1, we're flat on the left, vertical on the right. Again, B is greater than 1, we're flat on the left, vertical there on the right. All right, so our last example right here, so now we're dealing with A being a negative number and B again being a fraction. So the fact that A is negative and then E is equal to 3, again, domain is still negative infinity to infinity. That has never changed. But range is now going to be negative infinity to that E value, which is 3, and that's where our horizontal asymptote lies. Y equals 3. Special points are the x plus 6 equals negative 1, x plus 6 equal to 0, x plus 6 equal to positive 1. So we get -7, -6, and -5 for our x values. So again, we just substitute into our equation. -2 times 1/4 raised to the -7 plus 6 plus 3. We get -5. -2 times 1/4 raised to the -6 plus 6 plus 3 gives us 1. And -2 times 1/4 raised to the -5 plus 6 plus 3, we get 2.5. So we go ahead, plot all our information, dotted horizontal line at 3. -7, -5 is our first points. -6, 1 is our seconds. -5, 2.5 is our third. And again, we can see we're flat on the right side. And then we go vertical on the left side to hit those points. And there's our graph. And that's how we're working with our exponential graphs. There are other ways to go about doing it. You could work with the idea of our transformation similar to what we talked about from Unit 1 with 1.5, recognizing this is a shift of 6 left, 3 up, vertical stretch of the 2, reflecting over the x-axis, all that kind of stuff from your basic parent function 1/4 to the x power. And all that's perfectly fine. I just find it personally easier just to kind of worry about the coordinate points and just kind of do it more of almost like an arithmetic kind of approach. Find the numbers that work well, exponents giving us negative first power, 0 power, and 1 power, plug them in, plot our points, and make our curve that way. That's just my personal preference. All right, so that's our exponential stuff. We're also going to talk about some properties of logs and graphs of logs before we get into the idea of how to solve these different types of equations. So I'll see you next time for that one.